Well, this is new information.
There you go. This is page 9. So this page is dedicated to showing you the difference between what's called a relation and a function. You've got a relation, and then you've got a function. A relation is just when something is related to another thing, okay? There's no rules about it. They're just paired together. But a function in math is really important. A function, we're talking specifically about graphs. When you have a function, it means that if I take a number and I plug it into the equation, I'm going to come out to just one answer. Which is nice because ideally, if I took a number, plugged it in, and I came out with 2 different answers, wouldn't that be confusing? You know, if I said, hey, you plug 4 in, you plug 4 in. And then you got 6 and you got 8. But it was the same and you were both correct. That would be confusing, wouldn't it? So the concept of a function is if you plug something into a function, you will get one answer every time. You'll get the same answer as your neighbor. Yesterday we were briefly talking about it and I related it to a vending machine. I said, if you were working with a functioning vending machine, what should happen? Someone describe it to me. If it is a functioning vending machine. Right. You put your money in, you push the button, and it spits out one piece of food, right? One food item. That's a functioning vending machine. If it spits out 2 pieces of food, something's wrong, right? You're not supposed to get two items. Sometimes you get lucky. But like if it was an equation, if I plugged in one number but then I came out to 2, that's why there's a problem. That's not a function. So we're going to look at what is a function, what's a relation, what's a function, how do I know the difference between the two, and then how do I write them in different formats. We got a table, we have a mapping, and we have a graph. First of all, let's fill in some vocab words. A relation is any relationship between 2 variables. There's no rules. No rules.
Oh, we did.
I've got 3 that were out, so I'm just going to briefly. A function is a relationship between 2 variables. Notice that the definition starts out the same, but then all of a sudden it says, whoa, 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 wait a minute, where each input, and that would be your money if it's a vending machine, has exactly one output, and that would be your food that comes out of the vending machine, or your drink, whatever it is you're getting. Okay? So you put your money in, and you tell the vending machine what food you want, and it's going to produce that food, and only one of them, right? If it's functioning. So y'all know me, I relate things to food, and I always come up with corny ways to remember stuff. Now, the domain is the set of all x values. The range is the set of all y values. Domain is what I'm plugging in. Range is what's coming out. So domain is the money. Range is the food. You with me? Domain's the list of money. Range is the list of food. Now, we can't work with food. We're going to work with numbers. So let's look at this. Represent each function as a table, mapping, and graph. You'll notice right here we have this set of numbers. Do you see the little squigglies right here? You see the squigglies? Now you can understand why we did set notation first, because I wanted you to understand what the squigglies meant. Here is a set of numbers. Notice that it's coordinate points. So it's the point -5, 3, -1, 0, 3, -4, 1, 2, and 0, 4. Just a bunch of coordinate points. We're going to represent this in a table. So looking at our numbers, we want our x column to be in order. Just the x. wrote this yesterday, so make sure you write it. I think we wrote it here. You want your X column to be in order. So looking up here, the list, this is the roster method. Remember, let's practice the vocab words. This is a roster of points because it's listing them. When you're listing roster method, they should already be in order. So we can just look up here. We got -5, -1, 3, 1, 0. So I'm pulling the X values. Now I need to list the Y value that is paired to those numbers. The Y values may not be in order, that's okay. It's the X values that matter. So -5 is paired to 3, -1 is paired to 0, 3 is paired to 1, paired to 2, and 0 is paired to 4. So what you've just done is listed a function in table format. Some people call it T-table, some people call it T-chart, some people just call it table. Now let's look at this. We're going to put it in what's called mapping format. This is going to be a mapping. Very similar to a table in that you got your X's here, you got your Y's here. The difference is we're not writing them right next to each other. The difference is that these need to be in order. So this needs to be in order, and then this needs to be in order. So our X's are already in order over here, so I'm just going to copy them. -5, -1, 3, 1, 0. Now I'm going to go to the Y's that are nice and neat over here because it's easier for my mind to see them here. Instead of looking up here, I may look at the wrong number. I'm going to list these in order. What's the smallest number on the number line from here? -4. Then next would be 0. Then 2.
3.
Let's see the thought process here. We're looking and writing them in order, and then double check. So both of them are in order. So now what we're going to do is simply draw an arrow to show what does -5 map to. -5 maps to 3. What does -1 map to? 0. So this one actually works out nice. What does 3 map to? -4. And as you can see how to finish this, it does get a little crowded. That's why a mapping is sometimes not ideal because it can get a little hectic. But there's your mapping. All right, now what we're going to do is represent that set on a graph. These are just coordinate points, so here's a good refresher of how to plot coordinate points. If you recall, this is called the coordinate plane. It is showing you a grid where you've got your horizontal axis, which is the X values. Then you have your vertical axis, which is the Y values. And common sense kicks in here. If I'm going to the right, that would imply what type of number? Positive. If I'm going up, that would imply what type of number? Positive. If I'm going left, negative. And if I'm going down, negative. So common sense kicks in on what the signs should be. All right, we're going to plot, and again, my mind sees the T-chart easier than looking up here. When they're listed in the roster method, it's hard for my mind to see the numbers. But right here, I can clearly see -5, 3. So I'm going to go, hold my pencil. Do you remember what the middle is called?
The origin.
It's the origin. It's 0, 0. You always start your pencil here. Don't make a mark, but you just hover. We're going to go left 5, up 3. So left 5, and and then up 3. There's a point. Next, we're going to graph -1, 0. So from the origin, -1 means left 1, 0 means no up or down. 3, -4. From the origin, we're going to hover. We're going to go right 3, down 4. 1, 2. From the origin, we're going to go right 1, up 2. 0, 4. 0 means no right or left movement, then up 4. All right, you've just represented a relation in a T table, in a mapping, and in the graph. Now we have to answer this question. Is it just a relation, or is it actually a function, and why? So every time you just pair numbers together, you have a relation, okay? But you have to meet one condition to have a function. It's like a vending machine. If I plugged in this number, I had to come out with just one number, right? And none of them can repeat. So do you notice right here, if I plug in -5, what do I get? If I plug in -1, what do I get?
0.
If I plug in 3, what do I get? If I plug in 1, what do I get? And if I plug in 0, what do I get? At any point, did I plug in an x value twice and get like a different answer? So it's definitely a function. Another way to look at it is, look at the mapping. Here's where a visual on a mapping is helpful. How many arrows are leaving the x column? Only one single arrow. That means it's a mapping. Because that means that if I take and plug, I know you don't have -$5, but let's go back to a vending machine. If I take and plug a -5 into a vending machine, by golly, it's going to give me a 3. If I plug a -1 into the vending machine, I'm going to get 0. Like it's clear cut. If I plug this number in, I get this number. That's it. Nothing's repeated. So notice right here, let's take notes to yourself. Notice, draw an arrow. Notice only one arrow from each x. You only have one arrow coming from each x. That's a visual that it is a function. Now over here, here's another visual. Your x values are that number line. The x-axis is actually just the number line. So if you look at your visual over here on this number line, like when I plugged in -5, it came out to 3. When I plugged in -1, it came out to 0. When I plugged in 0, it came out to 4. When I plugged in 1, it came out to 2. When I plugged in 3, it came out to -4. Did you see any points stacked in the same x value, like in the same column? No, not at all. So that's another visual that this is a function, because there's no points stacked in the same column. Okay? Now, if you're looking at this and you're like, I have no clue what she's talking about, but it sounds good. This is only the first example. So let me get you to the second or third example, and then you can decide if you still don't understand it. So it is a function. Why? Because each x has exactly 1 y. Each x has exactly 1 y, or each input has exactly 1 output. All right, you try number 2. You're plotting it in the chart, in the table, in the mapping, and then on the graph. So everybody try. Did you notice that you wrote -3 possibly twice, or you drew 2 arrows coming out of -3? Did you see that? So that's something different, which is your clue that obviously something is going on here. So let's look at it. This is in roster method, or roster notation, which means the x's, if you look at them, they're going to be that first number. We've got -3, -1, 0, -3, 2. So technically this should be, now if you didn't put the -3, this one, this is the problem, right? If you didn't put that at the beginning, it's okay. You don't have to erase yours and rewrite it. But ideally, we would have listed it in order. You may have had the -3 down here, that's okay. And now that's going to change how my y looks if because I listed mine like this. Okay, now we're going to look at the mapping, right? So these are our x's and these are our y's. Y'all with me? Y'all sit up. So in order, I've got -3, but then I have another -3. You don't write it twice. Then I've got -1, 0, and 2. Then over here, I have let's see, in order, -3, 0, 2, 4, and 5. Right? Now we're going to draw arrows. So -3 maps to -3. Ooh, and -3 also maps to 5. -1 maps to 2. 0 to 0. And 2 to 4. Plotting these points. You should have put a point here. Here, 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 and here. Yes? Okay. Then it says, is it a relation or a function? Relation, function. Let's talk it out loud.
Relation.
Let's be nice. Everybody's learning. So why is it a relation? Why is it not a function?
-3 has 2 y out.
Yeah, we got a problem with -3. Think of a vending machine. I plugged in a -3 and it gave me a -3. And then my friend plugged in a -3 and they got a 5. So that wouldn't make sense. Like if we both plugged in -3, we should get the same number. And we didn't. We got 2 different numbers. If you have a highlighter, you could highlight the 2 arrows coming out of the -3, or you could highlight right here that this is the problem. Notice that they're stacked. If you need a highlighter, let me know. I'll throw you one. Anyone else? Just make sure you don't, oh, sorry. Make sure you don't take my highlighters, please. So you can highlight the problem. The problem is -3 has 2 arrows coming out of it. The problem in the graph is that I have 2 plots, 2 points that are in the same column, vertical alignment. And over here in the table, the problem is that I have -3 and -3. So there's plenty of clues that this is a relation, and it's because -3 maps to -3 and 5. That's a problem. -3 is mapping to two different numbers. Yes?
What if you put because the X has more than one line?
That's fine. That's also fine. That's the same thing. I love it. That's a great answer. Now, you might be thinking, okay, I'm starting to get the hang of this. Let me show you what's called the vertical line test, which is a faster way to check if you have a function in front of you by just looking at its graph. What if we don't have time to sit down and look at the T-chart? What if we don't have time to write a mapping? What if I just have the graph and I need to know immediately, is it a function? I'm going to look over here and I'm going to apply what's called the vertical line test. Did you have a comment? No. Yes. Oh, like answer the questions? Yeah, so what do you think the vertical, again, mathematicians name stuff to tell you what to do. What do you think it means?
Is it the vertical line?
It's the vertical line test. And so like where we highlighted on that graph to say, hey, this is a problem, that's your clue of what we're looking for. There it is. If it hits any vertical line, and when we say vertical line, we just mean like take your eyes and visually scan it. Okay? So if it hits any vertical line in more than one spot, it's failing the vertical line test, which means there was an input that got assigned to multiple outputs, and that's a problem. So let's come right here. If any vertical lines intersect the graph of the relation at more than one point, then the relation is not a function. The key aspect here is that it's intersecting at more than one point. Now you might need a refresher on which direction is vertical, which direction is horizontal. Couple of ways to remember this. Have you ever seen the horizon at the beach or a lake or a field? You know what the horizon is? When you look out, you have to be out like in an open area. You can't see it, you just look out right here. But if you go to the beach and you look out to the ocean, you're going to see the horizon, which is that horizontal line where the ocean meets the sky. So that's why it's called the horizon. Okay? You don't even have to go to the beach. You can go to Chickamauga Battlefield. There's a couple of huge fields out there that you can look out and you can see the horizon. Okay? That's one way to remember that horizontal runs like this. Okay? Vertical. If you're into sports at all, have you ever listened to, heard, or even, you don't even have to watch it, but you just know about it. Have you ever heard of someone's vertical jump, like when they do the NFL Combine? They're looking to see how high athletes can jump, right? That's the vertical, all right? So maybe that'll help. So we are imagining a vertical line, if you will, scanning across the graph. And if it intersects the graph in multiple places, it fails, which means it's not a function. So I want you to take a second and answer these three. You're just circling underneath. Answer those three. I used to have trash. Maybe I'll put it right here. What's that? It used to be right there, but I kept tripping over it. So, yeah. All right, you should be done. It's not bad, right? It really helps when you have a pointer, but I can draw the vertical, and clearly this is what?
It's not a function.
It's not a function. And if you want, take your highlighter and just drop a vertical somewhere. It doesn't matter where. And then take your pencil and be like, nope, that's a problem. It's definitely crossing in two places. What about the second one?
Yes.
Yeah, if I scan this, you can see it's only going to cross my vertical in one spot. It's only going to cross in one spot. What about this one?
Yes. No.
No.
Yes.
No. What do you
It's
think?
yes, because it doesn't.
Oh, got it.
No, it doesn't cross like that.
Yes.
No, it doesn't. It doesn't do that. It's just not showing.
This is when I would argue that that's probably not the graph to show you on day one of practicing this. If we had a graphing actually I can do it. Watch this. If we had a graphing calculator, maybe. I swept this room yesterday and I got all the trash. So if you would, please. There's a lot of trash. People that chew gum, y'all are leaving the wrappers in the floor. People that are eating, you're missing your mouth.
Hey, you stop watching this highlights?
LOL.
You scared Alex Linsky over here.
I did.
Are you gonna post this on your YouTube channel?
Yeah, it's on there.
And you're gonna hear us talking. Yes, let's upload. Are you gonna like edit us out? No, like, comment, and subscribe for more content. Actually, I'll just oh, there's a mic.
All right. Hey, guys, look up here. So I've drawn the graph. It's very similar. I think this one actually, it would be reflected. It actually goes like this, right?
Wait, it does.
It does. I know. But we're gonna work with this one. So when you first look at this, you might be thinking, are y'all with me? Everybody with me?
I'm watching off.
When you're looking at this, you might be thinking it fails the vertical line test because of right there in the middle. But I want to show you that I can zoom. Oh. I can zoom in.
What's happening right now?
I'm zooming in, like, big time.
It's not.
Do you notice I have zoomed in so much that, and I could keep going, but do you notice how this is ever so slightly to the left, and then this is ever so slightly to the right?
Oh, okay, that's not real.
It is real.
Look at that.
It is real. So what's happening here is the graph is coming in and just gradually approaching it. Then it's touching right here, and then it immediately, gradually leaves. So, does it pass the vertical line test? Yes, because it's only actually touching right there in one spot. Now, this was tricky. I would argue that's not the graph to show you on day one, but it's good. The question is, or the answer is yes.
I said the question was so questionable.
All right. So, yes, this is a function. You can put a single point right there if you want to remind you of this conversation that it is approaching and just touching right there. Huh? 940.
It's right there, big dog.
Hey. Go with me? All right. Turn the page. To the back. Now we're going to talk about discrete versus continuous. Take your highlighter and highlight these words. Discrete versus continuous. You need to know what discrete versus continuous means in terms of math. Discrete in like normal would mean like secretly, right? Not drawing attention to yourself. In math, it means disconnected. Discrete means disconnected. And then continuous would mean like connected, okay? So let's take some notes. Discrete functions have a domain that consists of only certain numbers in an interval. That's a very fancy definition. You could think of it as disconnected. Continuous have a domain that consists of all the numbers in an interval, meaning at some point you took your pencil and you drew like a curve. I don't want to say a line. Of course, it is a line here, but at some point you were dragging your pencil, right? You weren't like plotting points. You with me? So this is continuous. Not a lot to practice there because discrete's disconnected, continuous, you're dragging your pencil. Now we're getting into domain and range. This is exactly why I had to show you interval notation, set notation, and writing inequalities. These are two vocab words. So, domain, scan your pencil from left to right along the x-axis. We already said the domain is the x values. Range, scan your pencil from low to high along the y-axis. What type of inequality signs do we use for open circles? Do you remember? Fill this in.
Less than or greater than.
Yes. Then write the type of inequality signs that we use for closed circles.
And less than or equal to or greater than or equal to.
Yes.
Oh, I'll try some words that I never had that.
Yeah, do the signs. You should already know where the next part goes. We use in interval notation parentheses for open circles or infinity and brackets for closed circles. Now we're going to practice. We're going to do just discrete functions first, which means we're just looking at like a bunch of points. Domain and range. First of all, you should already know how to answer if it's a function. Remember, you check the what? Which column or which value do you check?
X.
You check the x. So you're looking to see, and if it helps, it may help to underline them, just the x's. So maybe your eyes don't, look at the numbers wrong. You're looking at the x's, you're answering the question if it's a function, yes or no. Did you get yes? Now we're going to answer. I don't know where it is.
There's something on your back.
Now we're going to answer domain and range. Domain is the list of x values. Range is the list of y values. You're literally just writing them as a set. So set notation lists the x's. So we got 1, 2, 3, 4, 5. That's the x's. Range, set notation, we're listing the y's. -5, 3, -1, 0, 2. Now, ideally, you would have put them in order, but I'm okay with you just writing the range. It's really not. It does get more complicated, but the foundation of it is this. So if you understand this, I can give you a more challenging problem. I would like you to do 7 and 8 right now. 7 and 8. All right, looking at number 7. Function, yes or no? No. This is a problem, right?
Yes.
All right, domain. Did you get 2, 3, 4, and 5?
Yes.
You do not have to list 5 twice. If you listed it twice, draw a line through the second one to remind you, nope, don't need that. You only have to list it one time. And then range, did you get -2, 0, 2, 3? I put them in order. So double check yours. You may not have them in order, but you should still have the same numbers. You're touching me. You are touching me. You're rubbing his back.
No, because he started doing it.
Definitely recording right now. Thank you so much. I appreciate it. Number 8. Number 8. Is it a function? Number 8.
Oh.
Careful. Oh, wait.
Actually, losing followers.
Well, this one's true.
It's not. It's not.
She's trying to gaslight us.
Yeah, because
It's
there's
not.
two.
There's 2 fours. There's 2 of the same thing. They're like the same.
I'm not that
There's
stupid.
actually
I say that is going to be a function.
Yeah.
I did that function or what?
Guys are on the
Okay,
same
okay,
spot.
hey, this is really good. I love when this happens in math because this is when you actually start learning crap faster than if I stand here and teach.
Oh my gosh, it's a function.
How is it a function?
Because
Okay, Hayden's trying to tell y'all. Hold on, Hayden's going to tell you.
I'm dropping out of high school.
That's really extreme. Let's don't go there.
I'm dropping out freshman year.
Brandon, Hayden, yes, you have it right. Brandon, say it.
They don't have different outputs or anything. So
Brandon, say your part. You're next. It's the same X and Y values.
they're all different outputs.
The output is the same.
You're allowed.
So they basically, this was a trick. So they basically listed the exact same point twice. So because when people are absent, they watch the video. And so if there's a lot of that chatter, it's really hard for them to pick up on me because I'm further from the mic, okay? Yeah, well, I just bought the mic. I'll buy the other later. So, you should notice that this point got repeated twice. And you might be like, no, that's not a function. But be careful. Notice the y value is the exact same. So basically, they wrote the same point twice just to catch you. So it actually is a function. You would never actually see it listed like that, okay? That's a gotcha question. It does make you mad. Y'all. So let's list our domain. We got, in order, -1, 2, 3, 4. And then our range, -3, -1, 4, and 6. So that was a gotcha question. Let's look at the last one. Here's where domain and range of continuous functions is slightly different. Now, it's the same concept. I'm listing the x values, I'm listing the y values. The difference is, if you recall what we talked about, how many numbers are between this point and this point on this line? How many numbers are between those points?
One in the center.
If I see one more post-it, I'm gonna-
Ada's ranch just put it on my back.
Hey, I teach high school, remember? So act like it. When you walk in here, you level up. You're not in 8th grade. You're not in 7th grade. Okay? All right, look up here. I'm trying to help you understand the concept of how many points are between any 2 points. So let's just think from 0 to 1. We're going to work in fractions, and it's actually going to be easier. You'll just trust me. What is halfway from 0 to 1? Go in fractions. Is that you doing that or you? Yes.
I'm losing.
What's halfway from 0 to 1? A half. What's halfway from 0 to a half?
1/3.
1/4. 1/4. What's halfway from 0 to 1/4?
1/8.
I heard it. 1/8. If you've not picked up on what's happening here, the pattern is that the denominator is doubling because I'm cutting it in half. What is halfway from 0 to 1/8? 1/16. What's halfway from 0 to 1/16? What's halfway from 0 to 1/32? 1/64. Can we keep going?
Yeah, but I don't.
But can we?
Yes.
Will you always have an answer for me? Yeah, all you do is double the denominator. Will we ever get to a point where you're going to be like, I can't double that, there's no number after it? No, we'll never get there. So I'm trying to show you the concept of, although physically, right, physically, how much space is between 2 points? Well, only so much, physically, because my fingers can't, you know what I mean? Mathematically, right, numerically, how much space is between any 2 points? Infinite. Enter the concept of continuous. There are so many numbers between these 2 points. I cannot sit down and list them. Can't do it. There's too many numbers. There's 0.01, 0.001, 0.0001. You see where this is going? Okay. So we have to do what's called interval notation or inequalities. Guess what? You've just had 4 days of practice on this. You should already know how to write it. Now you just have to know how to read it from the graph. If you're not listening, you're going to be in big trouble when we take the next quiz. So this is saying, tell me the domain, tell me the range. Your directions for doing this were up here. You're going to scan for domain by reading from left to right. You're going to scan for range by reading low to high. Okay? So watch. Just watch. Don't do your pencil or highlighter yet. We're reading the domain by looking at what x values are covered. Starting from the left, this graph starts right here. That's covering this x value, correct? It's down here. And it's running to this x value. All of the points on that line are going to run from -2 to 1 on the x-axis. From -2 to 1. You see that? So the domain would be between -2 and 1. Now, I personally like interval notation way easier. To me, this is harder for kids. So -2 to 1. Why did I put brackets on it?
Because there are
Closed circles. It's bounded. All right, I'm going to change highlighters. You may like the highlight technique. I'm going to change colors because now we're going to repeat this exact question, but with range. Hold on. I'm going to tell you it helps to turn your head sideways. Okay? You're repeating exactly what you just did, but now you're looking at the range of it. So turn your head sideways and think to yourself, how low is the graph to how high is the graph? So low, it starts here. And how high does it go? It ends there. So it starts at -3 and it goes up to 2. So the range would be from -3 to 2. If I had to say what's the most challenging part of all this, it's that right there. Domain and range. I've had seniors in my college math class that struggle to write domain and range. You're basically writing the interval of the lowest to the highest that the graph is going to cover. So if I was to sit down and have all the free time on my hands and list every single point on this line, I will only have x values that run from -2 to 1. I would only have y values that run from -3 to 2. That's the concept of domain and range. Oh, it does say, is it a function? I missed that part. Is it a function? Yeah. All right, let's look at the next one. Is it a function?
No.
No, clearly not. Definitely crossing multiple vertical line. Like if you dropped a vertical line anywhere, it's going to cross multiple times. But we can still read the domain and range. You may prefer to write the domain and range in interval first, and then write the bound and inequality. Some people find that easier. Okay, so what we need is the list of x values it covers, and the list of y values it covers. So I'm going to go back to my yellow highlighter. Remember x. Think of like collapsing the graph. Imagine this graph collapses to the x-axis. What would be covered? Well, the lowest point starts here, and it runs to there. -2 to 2. So -2 to 2. Now you can really see why I had y'all practice inequalities, especially the compound ones. Now the range, take your head and turn it sideways and imagine the graph, like an accordion, collapsing to the y-axis. Always do low to high, by the way. So the lowest point starts here and it runs to that point. So it's collapsing and it's running from -1 to 3. All right, let's try the last one. This is open, by the way. Open. This is an arrow. Is this a function?
Yes.
Yes, it is. Let's do the domain and range. Because we have an arrow, we're going to pull in an infinite, or an infinity sign. So let's read it. Domain, that's the x-axis. So imagine that graph. So the graph is like this. Basically, imagine it drawing like a magnet to the x-axis, straight down and straight up. So it's right here. Whoops. So it's right here, but that's an open circle, isn't it? That open circle matters. I'm trying to do my best. All right. So it's right here, and it runs to infinity. Correct? Doesn't that graph, like that keeps going that way? As it's going down, it's also going out, correct?
Yeah.
So it's definitely covering that entire side of the number line. So our domain is -3 to what? Infinity. -3 to infinity. Now, how do you write that as an inequality? X is greater than -3. range, that's the y value. Look at the graph. I'm going to put the range on the board. Hold on. Trying to make sure you get this. Yes. And it is gray. Alright, look at the range. So take your head, turn it sideways. As this arrow is pointing like down here, is it covering all these y values? Yes. So the range is coming from the bottom, and it's coming up here, and it stops right there with an open circle, right? So it's coming from negative infinity up to, let's see, positive 3. Open. So how do you read that, like, how do you write that as an inequality? Well, where's the infinity? It's to the left of the 3. So it's x is less than 3. Not x, y. Oh my gosh, y'all, you didn't stop. I wrote x. Y'all should have stopped me. Can you please, really quickly, I got caught up in the x's. Can you make these y's? It's just really annoying.